NASA's Voyager 1 has traveled the furthest. This remarkable rocket continues its amazing venture, communicating flawlessly across space and transmitting significant information from the deepest areas of the universe. For almost 50 years, this phenomenal space probe has revolutionized our understanding of space. However, as of late, the space apparatus has been transmitting disturbing information back to Earth, leaving the entire space industry in shock. These troubling signs could be the result of a technical breakdown, or perhaps the activities of extraterrestrials. Join us as we uncover the reality behind these remarkable transmissions. Since the beginning of recorded history, researchers have been enthralled by the secrets that lie beyond our heavenly boundaries. This interest prompted the groundbreaking debut of the Explorer 1 and Explorer 2 shuttles, among other wonderful space missions. These momentous missions, which had been discussed for quite some time, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5 of that same year, Explorer 1 followed suit. These twin probes, each weighing a significant 720 kilograms, equivalent to a small vehicle, were propelled into space during a unique alignment of the outer planets. Throughout their staggering odyssey, these courageous voyagers navigated in different directions and at varying speeds, leading to a crucial moment on December 15, 1977, when Explorer 1 outpaced its identical twin due to variations in their paths. Since then, Explorer 1 has become a significant asset, providing us with a wealth of information and unraveling space-related secrets. Before we delve into Explorer 1's startling new discovery that stunned the entire space industry, let's explore the exceptional images the rocket took during its pivotal Jovian imaging mission in 1978. Explorer 1 was positioned roughly 265 million kilometers from Earth. From this vantage point, it transmitted a stunning number of photos back to Earth. In January 1979, it embarked on an exceptional 100-hour endeavor, capturing a mesmerizing time-lapse film exhibiting 10 rotations of Jupiter. A cornucopia of 3,750 pictures allowed us to observe Jupiter's magnificent dance in vivid detail. In the ensuing months, Explorer 1 wandered through the Jovian moon system, making a striking revelation: the presence of a small ring surrounding Jupiter, as well as 2 new moons, which further expanded our understanding of Jupiter's fascinating domain. To ensure safe passage and prevent a potential impact with Titan, a moon of Saturn, corrective maneuvers were executed. Explorer 1 continued its celestial journey around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. With the culmination of the Saturn mission, researchers decided to conclude the Explorer planetary mission, pushing both Explorer 1 and Explorer 2 beyond the bounds of our planetary group, leaping through space at an astonishing annual rate of 325 million kilometers. In January 1990, another chapter began: the Explorer interstellar mission. During this stage, Explorer 1 delivered some of the most famous photos in history, immortalizing the Sun and the majority of the planets. One person who played a vital role in extending the missions beyond their initial objectives was the prominent astronomer Dr. Vasily Sands. As part of the Explorer mission's imaging team, Dr. Sands ardently advocated for capturing one final set of pictures as a goodbye gift to humanity. Against all odds, his steadfast determination bore fruit. On February 14, 1990, when Explorer 1 was positioned 6 billion kilometers from the Sun, it embarked on a visual excursion well known as the Family Portrait, a planetary group photo. These stunning images, totaling 60, added to the shuttle's remarkable collection of 670 photos. During its encounter with Neptune, Voyager 2 achieved an extraordinary milestone by recording wind speeds exceeding 13,100 meters per second, the fastest winds ever documented in our planetary group. As the rocket ventured within 280 miles of Neptune's methane-rich atmosphere, it provided remarkable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was found to be one of the coldest residents in our planetary group, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's peculiar features, such as nitrogen gas causing ice volcanoes to erupt and push icy particles 5 miles into its nebulous atmosphere, also captivated our imagination. These exceptional discoveries expanded our comprehension of the vast variety and complexity of celestial objects residing in the farthest reaches of our local planetary group. Don't go anywhere. The Explorer 1 rocket has recently made one of its most frightening discoveries. But first, let's find out what it has achieved in the last 45 years. The accomplishments of the Explorer twin tests have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe, shattering previous assumptions regarding these far-off worlds. These moons, once thought to be sleeping and severely scarred, similar to our own moon, turned out to be teeming with geological activity. Explorer 2 specifically achieved several exceptional feats during its journey. It made history in 1986 by becoming the first shuttle to fly by Uranus. Just 3 years later, it achieved another remarkable feat with a flyby of Neptune. To this day, it remains the sole rocket to have ventured on such a path. As the Explorer program continued, NASA implemented a variety of measures to increase the spacecraft's operational lifespans. In recent years, unnecessary parts and heaters were deactivated to conserve energy, ensuring that these courageous explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this remarkable project from the very beginning, the culmination of the Explorer missions is both a moment of pride and a tinge of melancholy. Their steadfast dedication and passionate efforts have far surpassed initial expectations. The wealth of data returned by the explorers has provided valuable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Explorer 1 and Explorer 2 were no ordinary space probes. They were meticulously constructed to be stable platforms, with a rotation rate over 15 times slower than the hour hand of a clock. This design minimized visual haze as the spacecraft captured images and data while journeying through the infinity of space. Even before their encounters with the outer planets, their impressive imaging abilities began to astonish scientists and the public alike. The spacecraft started sending images of Jupiter before even reaching the gas giant. These early images, displaying the swirling clouds and the iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, somewhat larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments identified peculiar signals from Io, which were confirmed by the distinctive images they captured: towering volcanic ash plumes and volcanic scars on the surface. Distant spacecraft Explorer 1 continued its solitary journey for an additional 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to witness it, NASA didn't publicly announce this remarkable achievement until 2013. What procedures ensured the Explorer's success? One aspect of the mission stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played an essential role in propelling Explorer 1 and Explorer 2 on their audacious mission to explore the outer reaches of our solar system. To reach these distant destinations and gather valuable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assists provided just that. Imagine the two fearless rockets, Voyager 1 and Voyager 2, embarking on their grand tour through the local planetary group. Instead of relying solely on their motors, they engaged in a celestial dance with some of our local planet's heavyweights. These planets formed a group that performed an incredible dance, leveraging their vast gravitational pull to slingshot the spacecraft on their way. This method enabled them to preserve priceless fuel and gain the necessary speed to visit numerous destinations. Let's investigate the fundamentals of gravity assist, also known as a gravitational slingshot. The idea behind this maneuver is to transfer some of a planet's energy to the spacecraft passing by. Imagine Explorer 1 approaching Jupiter, a massive gas giant with a matching gravitational pull. With meticulous precision, Explorer 1 swung by Jupiter at the perfect angle and speed. Jupiter's gravity tugged at the spacecraft, accelerating it to a higher velocity and providing it with a significant boost. Performing a gravity assist maneuver requires exceptional precision. Had Explorer 1 approached Jupiter at the wrong angle or speed, the slingshot might have resulted in a disastrous deviation from its intended course. The level of accuracy required is daunting. However, the creative minds behind these missions carry them out successfully, performing gravity assists multiple times and propelling the Explorer spacecraft on an astonishing journey through the local planetary group. Explorer 2, for example, utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of vital importance in making the Grand Tour possible. The Explorer missions owe much of their success to these gravity assist maneuvers. Explorer 1 reached interstellar space, with Explorer 2 quickly doing the same, all thanks to the accuracy of these maneuvers. The concept behind gravity assist is simple, but the execution is extremely complex. Explorer 2's Grand Tour required a level of precision where missing any of these slingshots could have resulted in a failed mission. However, the dedicated individuals behind these missions were determined and steadfast in their pursuit of knowledge. While gravity assist played a significant role in exploring the universe, another critical component ensured the success of the Explorer missions. The Deep Space Network, DSN, often considered the interstellar phone line that kept us connected to our brave Explorer probes as they ventured into the great unknown. The DSN, though less flashy than a spacecraft, is equally indispensable. It's a system of massive radio antennas strategically positioned around the world, including locations in California, Spain, and Australia. These gigantic dishes, ranging from 26 to an amazing 70 meters in diameter, act as vast amplifiers facilitating communication with spacecraft that are orbiting other planets. The Explorer probes, equipped with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space. To make sense of the data they sent and to provide them with new instructions, a robust communication system was essential. That's where the DSN came into play. Imagine Voyager 1 on its way to the outer reaches of the solar system, sending a message back to Earth as a weak signal traveling at the speed of light. The signal weakens by a factor of many millions by the time it reaches Earth, a whisper across the void. Using its gigantic antennas, the DSN captures that whisper, locks onto Voyager's weak signal, and transforms it into data that scientists can analyze. But the DSN doesn't just receive signals, it also sends commands. The Explorer missions are dynamic endeavors, requiring scientists and engineers to adjust trajectories, redirect the spacecraft, or tweak instruments. The DSN transmits these commands into space to reach Voyager and guide it. It operates as a dialogue between two parties, between Earth and the farthest human-made objects in the universe. One remarkable aspect of the DSN is its continuous operation. It works 24/7, listening for those distant signals. It's like an unblinking eye on the universe, ensuring that we stay connected to our space probes, even when they are billions of miles away. The Explorer missions stand as a testament to the power of collaboration and innovation. While the spacecraft embarked on their grand journeys, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. But did Explorer 1 experience a breakdown, or were aliens involved? Throughout its remarkable journey through space over 45 years, the Voyager 1 space probe has remained healthy, diligently performing its mission. However, in recent times, experts have noticed some abnormalities in its performance that have sparked interest and curiosity. Explorer 1 is currently sending peculiar signals back to Earth, creating the impression that it is uncertain about its exact location coordinates. What makes this discovery even more perplexing is that the initial data received from Explorer 1 were incomprehensible and unimaginable, leaving NASA scientists puzzled. Upon examination, scientists found that the system responsible for the erroneous data was the Attitude Articulation and Control System, AACS. This embedded equipment is responsible for measuring, reporting, and adjusting the spacecraft's position in space. It has an antenna directed toward Earth, enabling it to send data back home. The malfunction occurred when the software abruptly began sending its telemetry data through a faulty embedded computer that had been dormant for years. NASA engineers were able to correct this anomaly by instructing the spacecraft to resume sending data through the correct computer. Thus, uncorrupted data from Explorer 1 is once again reaching NASA. However, the question remains unanswered. Why did the spacecraft switch to the malfunctioning computer in the first place? NASA scientists have put forward a hypothesis that a faulty command from another onboard computer might have triggered the strange behavior, but they have yet to pinpoint the exact cause. To get to the bottom of this mystery, Susan Dodd, the project manager for the interstellar mission, stated their intention to conduct a thorough memory readout of the spacecraft and fully analyze its operations. This in-depth examination aims to determine the cause of the telemetry issue. Despite the erratic data, the spacecraft itself appears to be working as intended. None of the spacecraft's fault protection systems have been triggered. As such, Explorer 1 has not been forced into safe mode, and its signal remains strong. A possible factor contributing to this inconsistency is the harsh environment of space. Radiation from the cosmos and extreme temperature fluctuations can pose challenges to the operation of a spacecraft like Explorer 1. Cosmic radiation consists of high-energy particles originating from distant stars and galaxies. These particles can penetrate spacecraft structures, causing electrical disturbances, signal distortions, errors in memory, and data corruption. Additionally, temperatures in the vastness of space can drop to bone-chilling lows or soar to scorching highs, putting immense stress on the spacecraft's components. Despite the rigorous testing and attention to detail involved in the design of Explorer 1 to withstand these conditions, the harsh realities of space can still take a toll over time. Another intriguing possibility that has captured the imagination of some is the idea of extraterrestrial interference. Could Explorer 1's anomalous behavior be attributed to the actions of intelligent beings from beyond our solar system? While this idea may seem more akin to science fiction than reality, it is not entirely outside the realm of possibility. The vastness of space and the countless exoplanets it harbors leave room for speculation about societies significantly more advanced than our own. But before leaping to conclusions of alien intervention, scientists are diligently examining every aspect of Explorer 1's irregular behavior. Whether the spacecraft's anomaly is due to a technical glitch, cosmic radiation, or something else entirely remains to be seen. One thing, however, is certain. The mysteries of space keep captivating and inspiring us, driving our relentless quest for knowledge and understanding of the cosmos.